Hey guys, welcome back to CMTEQ channel in this tutorial on basic motor control circuit. Now, motor control is really fundamental to electrical engineering and even many other fields because without controlling machines and motors and all sort of device moving part, it will be difficult to perform anything. We will be moving back to Stone Age. So this is why, as an electrical engineer, you have to understand your basics to advance of how to control a motor with maximum efficiency and getting the job done. So in this tutorial here, I'm just basically going to look into just a basic part of the difference between the two schematic here. Now, this is a ladder diagram, okay? So this is a ladder diagram and this is a schematic diagram. So what we have here on my left here, this is performing the same function as this one on the right, okay? The function is that to control this motor here. So that's the function the two are performing, but they are wired differently, okay? So on my left here, we've got the control circuit here, okay? Forget about the supply part because we basically here, there is nothing much to it. We've got a 480 volt AC that is being supplied. We're stepping it down to 120 volt. So that means our motor here is a 120 volt AC motor. So we have to step it down, right? Now, then we come to the control part. Now the control part here on the ladder side is made of a toggle switch. The toggle switch that basically must control this coil here. So when you press the switch close, this coil here will energize, okay? Now, because this coil M1 is linked to this M1, which is a normally open contact, so that basically when this coil get energized, this one also will close, okay? And when this one close, it's allowed the current to now flow from here to the motor, and the motor is going to start turning. So this is how this one operates. So that basically how you wire them when you use PLC control. Now, on my right side here, we've got a relay coil, okay, which is also known as, you guessed it, an electromechanical relay, which basically the same circuit apply. We've got the 480 and step down. We've got a fuse here that will just ensure that we don't draw more than what we're supposed to draw. Otherwise, the fuse here is going to cut it off, okay? That's the same function that these two fuses here, they have, right? Now, when you close the switch here, the current will then flow this way down to the coil here, and this coil will get energized. It will generate an EMF, an electromagnetic field that will then pull this contact here close, okay? So when the contact here close, then the motor will turn. This is a simple electromechanical relay. These relays are actually very widely used, even though sometimes nowadays they are being replaced by some solid state relay. But solid state relays, they can just take as much as these electromechanical relays, which are very robust and they can work in different environments. Now, just a note on solid state relay versus electromechanical relays. So basically, the first choice is to go for electromechanical relays. Why? Because they are cheap, right? They're cheap, and that basically means if it's broken, you can replace it quite easily. And that is in contrast with your solid state relay, which is made of some electronic circuitry inside there, and it is expensive, right? And they have a very long life expectancy, so they last very long, almost forever, okay? So that's the only difference between the two. So if you've got money, you've got a high budget, you don't have to worry about where the money is coming from, you can go for solid state relays. Otherwise, you can go for electromechanical relay, which are cheap. So basically, the electromechanical relay will have the number of maximum switching it can perform before it starts to run out. So this particular one, let's say on a data sheet, they will tell you, no, this one can switch 100,000 times. Click, 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 click. After 100,000 times switching, then the relay contact will run out, or they will tell you they're not going to be any more guarantee that it will continue to work as expected. Maybe there's going to be a high impedance that will increase the power losses because it's not going to be a very good effective contact. then in that case you just go ahead and replace your relay because it's cheap to acquire. But if you do not want that kind of a problem to arise on your circuit, then you go for the bad boy solid state relays. All right, so let's move on. Okay, now, so that basically the operation here. So the relay is energized, a contact close, and the motor will start turning. So it performs the same operation as the one on the left. Right. Now we all agree that these two diagrams, they perform the same functions, but we know that there are always advantages and disadvantages to whichever control circuit you want to implement. So let me know on the comment below if you find disadvantages to this circuit or its advantages versus this one on the left here. Then we can have a discussion. Now here is a simple basic motor starter circuit, right? So here we've got what we call a control circuit, right? And a power circuit. Now the power circuit here is basically where you've got your three-phase. So this is your three-phase motor here. You're going to connect your three-phase power source, line 1, line 2, and line 3. Then you have this motor starter contactor here, and you have your motor wired, right? This is very basic, simple. We don't have overcurrent protection and overload protection, nothing. Then you have a command or control circuit. Now, this control circuit is basically the same one that we saw previously. So when you hit a run, button here, the coil will energize and this contactor will close, okay? And the motor will start. Now, as you can see, this is a push button, right? So you push release. So even after you release this, the motor is not going to stop. Why? Because this M1 here is going to close and it will remain closed. This is also known as a latching circuit, right? So this latch circuit is possible only because of this M1 here, which is a seal in contact. So even after releasing this momentary push button here, this one will remain latched, it will remain closed, and your motor will continue running. But how do you do if you want to stop this motor here? Obviously, if you pull the plug, you remove the power, you cut off your L1 and L2, then your motor should be able to stop. But that is dangerous. So you should be able to have a button here that should cause this motor to stop. Now, where do you include your button? Do you insert your button here? Or do you insert your button here? Where do you put your button so that you can deactivate or disconnect this latch circuit from taking power into your motor? Right, now this is very simple. So the simplest way to implement a stop button would be easy. So let's just redraw our circuit here. We've got L1, right? Now we're going to include a stop button in line. Right now, this stop button must be a normally closed button, right? So we're going to draw it like this. So this is the stop button. So emergency. So when you hit this, then you open the circuit. Then in line with it, we're going to draw our normally open push button, right? So this is a momentary switch that we are basically hitting to run the motor. So this is going to be the run, okay? So right here in parallel with it is where we've got our normally open contact, okay? That is the seal in contact, which is affecting our latch circuit functionality. And we're going to have our relay coil here, okay? This is a ladder circuit. So basically here we'll have our L1 and we've got our L2. So if this is M1, this is also M1, as we said earlier, that these two are linked. Once this one is energized and this one is also closed and the motor start running. So right now you hit a run, your motor is going to start running. You hit stop, the motor will have to stop. So you don't have to pull the plugs or do some funny tricks to get that motor to stop running. So this is it for this tutorial. Thanks for watching. If you liked it, please subscribe to CMTEQ channel and give this tutorial a thumbs up. Stay tuned for more motor control circuit coming up on CMTEQ channel. Until next time, cheers.